Hello, my favorite freshmen. We are about to continue on with, this is still chapter 20, and this is still part of section 3. The last video was going over formula writing and transition binary compounds. So now we're going to continue on, still section 3, talking about writing formulas. We're going to name some compounds, and then we're going to jump into polyatomic compounds. Okay, just again a reminder, make sure you have your periodic chart out in front of you. So here we have the name lead, Roman numeral 2 oxide. Now you can see that lead, the reason there's a Roman numeral there, remember lead, if you look at your periodic chart, has more than one oxidation state. Because it has more than one oxidation state, you have to give me Roman numerals in the name. And that is what we have going on there. So what I would continue to do, like I showed you before, let's go ahead and put the oxidation states above each of these elements, even though they're in name form. So what we're going to do here, I'm giving you all names, and now we have to write the formulas for these names that I'm giving you. So lead, I know, has an oxidation state of 2, because that's what it's telling me right there. Oxide, we should know by now, that is oxygen. Oxygen has an oxidation state of 2. To write that, obviously, these oxidation states will switch in the formula itself. They both have an oxidation state of 2, so they cancel each other out. I would not write it like that. If you did, I wouldn't mark it wrong. I would just remind you to make sure that those cancel out and leave it at PBO. So now we have, let's take a look at the next one, manganese, Roman numeral 2 oxide. So that's telling me manganese, the scientist is choosing the oxidation state of 2. Oxide is our oxygen, probably have that memorized by now, has an oxidation state of 2. And now to write manganese oxide, again, they would cancel out, and there you have it. Let's try another one. We've got tin, Roman numeral 2 bromide. Tin, oxidation state of 2 because I've got that Roman numeral there. Again, tin has more than one oxidation state, so we have to have a Roman numeral there in the name. Bromide, if you look at your periodic chart, it has an oxidation state of 1. These oxidation states switch, so I will write the formula SnBr2. Again, the 2 goes after the bromide, the 1 will go after tin. So we're still switching here because we're writing the formulas. In the formula, you have to show me how the oxidation states switch, as we did just right there. So now we have copper, Roman numeral 2 chloride. Continuing on here, copper has an oxidation state of 2 because I can see that there by the Roman numeral 2. And then chlorine has an oxidation state of 1. So let's write the formula. If you haven't already, I bet many of you have. Whoopsie, sorry about that. CuCl2. Again, the 1 goes after the copper, the 2 goes after the chlorine. Okay, last one that we have here is iron, Roman numeral 3 fluoride. Iron, because of this Roman numeral here, I know has an oxidation state of 3. Because if you do look at your periodic chart, your choices are either 2 or 3 for the oxidation state. But because I've got the Roman numerals here, I know it's 3. And fluoride has an oxidation state of 1. Remember, in all of these, on all the nonmetals, go with the top oxidation state or atomic charge. Okay? Only on the nonmetals are we doing that. In the metals, we have to choose, and you have to tell me which oxidation state you're using on those transition metals because many of them do have more than one. So let's go ahead and write this formula for iron 3 fluoride. Fe F3. Again, the 3 goes after fluorine, the 1 goes after iron. Okay, ready to go? Let's continue on with, now I'm going to actually give you the formula and you have to give me the name. And this is going to be how our quizzes and tests are structured. I give you the name, you give me the formula. You give me the formula and you give me the name. And I have a nice sized worksheet that we're going to be actually doing in class either today or tomorrow. Okay, so naming the compounds, let me get them all up here so I don't have to mess with my pen. Here we go. So we can see that that's cobalt, and we have fluorine there. I know that this 2 actually belongs to cobalt, correct? But the very first thing you want to do when you look at this, is it ionic or covalent? In this case, we're still dealing with all ionic compounds. They're metal plus a nonmetal. But very soon, if it's a covalent compound, we'll be using prefixes. In this case, if you just scan all 5 of these, you can see that they are all ionic. Once you establish whether it's ionic or covalent, in this case they are all ionic, the second thing you need to ask yourself, does that metal, does that cation, does that first element there have more than one oxidation state? We are dealing with cobalt here, CO. It does have more than one oxidation state. If you look at your periodic chart, it has an oxidation state of 2 or 3. So I know 2 is used because I can see that 2 after fluorine, and I know fluorine actually has an oxidation state of 1. So you could do this if you want to. Maybe not as necessary when naming the compounds, but more importantly, when that metal, that first element, has more than one oxidation state, you have to give me a Roman numeral in the name. So let's give that a try. Here we have cobalt, Roman numeral 2. Again, this is the oxidation state of cobalt in that formula, and they still end in IDE, fluoride. Let's try another one. Here we have CuCl. It is ionic. That's the first thing you should figure out, ionic or covalent, like I said. Then, does that first element have more than one oxidation state? Copper. Yes, it does. The choices are 2 or 1. Well, I know chlorine is 1, and there's a 1 after copper, right? Because there's nothing written there. So it must be a 1 because there's nothing after chlorine. So I will write that copper, Roman numeral 1, chloride. Very good. If by chance it was a 2, it would have had to have been written CuCl2. See the difference there? And how I can tell which oxidation state was used for copper. Okay, the third one we have here, Fe2S3. It is ionic. That first metal does have more than one oxidation state. So I know I have to put a Roman numeral in the name, only in the name. I never want to see Roman numerals in the formula. So when I look at this, this 3 belongs to iron, and this 2 belongs to sulfur, because remember they're switched in the formula. So let's go ahead and try and name this. We have iron, Roman numeral 3, sulfide. Very good. Hope that makes sense. Next one, we have antimony with chlorine. Again, ionic compound, metal plus a nonmetal. Yes, that first element, the metal, has more than one oxidation state. So I have to give a Roman numeral in the name. And this 3, I know, belongs to antimony. Okay? And a 1 for chlorine. But that's okay. We don't need Roman numerals for those nonmetals. Only these transition metals that have more than one oxidation state. So let's write it out. Antimony, Roman numeral 3, because antimony does have more than one oxidation state. Chloride, ending in IDE. All ionic compounds end in IDE. Last one here, we have lead with oxygen. Now, when you look at that, it is an ionic compound, and lead does have more than one oxidation state. Now, we know oxygen is 2, correct? Now, the choices for lead are 4 or 2. Now, if oxygen is 2, and we choose lead as being 2, they would cancel each other out, correct? Because otherwise, I would have, if we chose the oxidation state of 4, it would be written like this, which actually, in simplest form, would look like this. So by process of elimination here, I look at PbO. I know the oxidation state of that nonmetal. Okay, we know that because we choose that top atomic charge oxidation state. and we know it's going to be 2. So it had to be a 2 used, because if this is a 2 and this is a 2, they cancel each other out, giving you the PbO. Again, lead has more than one oxidation state. You have to give me that Roman numeral in the name. So let's give it a try. We have lead, Roman numeral 2, oxide. Okay? Hope that all makes sense. If you have any questions at all on this, please make sure to bring it to the table in class either today or tomorrow, okay? So let's go on. I think we've got that down. Here are your polyatomic compounds. I'll pull all of this up for you. Yes, you have to memorize all of these, okay? You can see there's 4, 5, 6, 7, there's only 8 of them to memorize. When you get to chemistry your junior year, I think you have like 20 or 22 that you'll have to memorize. So this really isn't so bad. So don't complain too much, because this is just going to help you out your junior year when you have a lot more to memorize. So yes, I do want you to memorize these. You can see I give you the charges there, because a polyatomic, let's back up a little bit, are 2 or more elements, like I have stated here, that are covalently bonded. But what they do is they act like one element, and they bond with other elements and make ionic bonds. So these guys will combine with other elements, making ionic bonds again. With a polyatomic, like for example here, we've got NH4. That will always be NH4. You can't break it apart. You're not going to separate that. And the oxidation state for NH4 is 1. Oh boy, sorry. Is 1. Let me get my pen going. Is 1. That's what I'm telling you right there. That's the oxidation state for ammonium. The next one, acetate C2H3O2, has an oxidation state of 1. Chlorate ClO3 has an oxidation state of 1. Hydroxide OH has an oxidation state of 1. Yes, you need to memorize these because they are not on the periodic chart. Nitrate, oxidation state of 1. So the majority of them have an oxidation state of 1. The last 3, a little different. Carbonate and sulfate, they both have an oxidation state of 2. And phosphate has an oxidation state of 3. Okay? When using these and combining these with elements, those oxidation states are the oxidation states that are going to be switching for those particular polyatomics. Okay? Again, you need to memorize these, get used to them, get used to their names, and so forth. Again, I suggest making flashcards. I think that's the best approach to memorizing these. I think these are probably new for most of you. A few of them might be familiar. So let's go ahead and try and write some formulas and some names using these polyatomics. I think I might run out of time here shortly. So we'll get through a couple of them anyway, and I will continue on in the next video. So here we have sodium plus acetate. Sodium, what kind of oxidation state does sodium have? 1. Let's put a little 1 there. Again, this alleviates mistakes. What is the oxidation state of acetate? 1. Again, keep this together. And a lot of times you will see these polyatomics in parentheses. We keep them in parentheses because, again, they act as one element. Acetate, even though it's C2H3O2, polyatomic means many atoms that are together, but they behave as one. So let's go ahead and try and write the formula for these. This one here. Na C2H3O2. I suggest keeping parentheses around these even when there isn't, if you have a subscript here, that is the time that you actually need parentheses around your polyatomics. But I find that with most of the freshmen, it's easier and clearer to them if they just put parentheses around them at all times. That's not a wrong thing to do. I'm going to erase that there. But see, again, the 1 comes after acetate, and the 1 comes after sodium. They cancel each other out. Again, we don't write our 1s, and there you have it. With the name, what's nice about these polyatomics, their names don't change. Their names are what they are. Acetate's acetate, nitrate's nitrate, phosphate's phosphate. So you don't have to change or add any endings to these.